Excel's financial functions are versatile, and we can manipulate them to get all sorts of information. We're already familiar with the terms interest rate, present value of loan or investment, number of periods, and future value of the loan or investment, as they formed part of our PMT, PPMT, and IPMT functions. Let's now focus on them one by one and see how they can be useful given different scenarios. What if Ishan still wants to take out a loan of $50,000 but can only afford to make monthly payments up to a maximum of $1,100 per month over a period of 4 years? Ishan is comparing various loan options but wants to know what is the maximum interest rate he could consider given these constraints. We can use the rate function to solve for the interest rate. This function returns the interest rate per period of a loan or an investment. Click on cell B6 and start typing in the rate function, and you will see the syntax. The first 3 terms are necessary, so let's reference the loan term cell and multiply by 12 to get the number of periods. Then, we need to click on cell B4 for monthly payment amount, and lastly, reference the principal amount. Now there are also 3 optional parameters we can include that are these ones shown in square brackets. We've already discussed future value and type, and let's leave both of these blank. Excel will then assume Ishan wants to pay off the entire loan in 4 years' time and will make payments at the end of each period. In Excel 2016, there is an additional optional parameter called guess. Just like the name suggests, this allows you to insert an initial estimate as to what the interest rate may be. If you leave this blank, Excel will start with a default value of 10% or 0.1, but this is just a starting point, and Excel then uses an iterative procedure to converge to the correct interest rate. Let's leave the guess argument blank and press enter. Oops! It seems like we've encountered an error. If you see this error message appearing in a cell, it can mean a few different things. The first thing to do is to check that you have correctly referenced cells. You should also check the format of all cells in case any of them are in an incorrect number format. Also, sometimes the number could be too small or too big to display in a cell, so you may have to adjust the cell size or increase the number of decimal places using this icon and see if this solves your problem. Lastly, check the actual cell values of referenced cells in case they're causing the issue. Now the last thing is what is causing the error in our example. Recall that when we calculated the PMT function, we ended up with a negative number as it was a cash outflow. Cash outflows are represented by negative numbers and cash inflows are represented by positive numbers. If the payment value is positive like this, the principal amount is not seen by Excel as being paid back or offset during the loan term. Therefore, we need to ensure the payment value is a negative number, so if we just insert a negative sign before the 1,100, this should solve our problem. Sure enough, we now end up with a value for rate. However, this is an incredibly low interest rate of 0.22%, which sounds too good to be true. This is because the rate function actually solves for the periodic interest rate, which in our case is the monthly compounded interest rate. To get the annual interest rate, we have to multiply the entire function by 12. This now gives us an interest rate of 2.7% per annum, which is the upper limit that Ishan can accept for a loan, if he wants to make monthly payments not exceeding $1,100 over 4 years to pay back the loan. Now, Ishan's search for a suitable loan is proving a bit challenging. He decides to change his strategy by figuring out how much he is able to borrow under a specified interest rate and loan term. He decides to set aside some money for a rainy day and is now willing to fork out $1,000 in monthly payments. We can use the PV function to find out how much Ishan can borrow if he takes out a loan for 6 years at an interest rate of 4.5% per annum and makes monthly payments of $1,000 towards it. Just like we plugged in the respective input values for other financial functions, PV is no different. Let's go ahead and do this. Now don't forget to divide the interest rate by 12 and multiply the number of periods by 12. Now we end up with a negative loan amount. Again, this is because our monthly payment value has been input as a positive value. If we change this to a negative, since it's a cash outflow, our loan value will automatically become positive, which reflects that it's a cash inflow. Now Ishan is pretty happy that he can borrow more than the initially planned $50,000 if he chooses to invest into expanding the Food to Go app to include restaurant reservations. But there's still one more question in Ishan's mind. What if he wants to borrow an amount of $75,000 instead, at the same interest rate of 4.5%, while sticking to making monthly payments of $1,000? How long would it then take him to pay back this loan? We can use the NPER function to work this out, and we have all the values required in its syntax. But before we start, let's add a negative sign before our monthly payment value so that our function works correctly. Now let's reference our cells again. Here we go. And let's leave the type parameter blank and press enter. Can this be right though? Will it really take Ishan over 88 years to pay back this loan? It's not like he's borrowing that much more. What we forgot was since we've entered everything monthly, the loan term is also being displayed in terms of the number of months. Therefore, we need to divide this function by 12 and we will end up with 7.35 as the loan term, which means it will take Ishan about 7 years and 4 months to pay back this loan.